We usually think of AI as this amazing machine that just gives us answers, right? But what if it could do more? What if it could actually help us ask brand new questions and maybe even help us make the next big scientific discovery? That is the wild, fascinating idea we're going to unpack today.
I mean, think about it. Today's language models have basically read everything, every scientific paper, every textbook, way more than any human ever could. So they have the entire library in their head. But here's the big question. Having all that information is one thing, but can you use it to spark a truly new creative idea? That's a whole different ballgame.
So, look, the real problem here isn't about just knowing stuff. The real bottleneck is teaching an AI how to deal with the kind of abstract, open-ended, and frankly, messy problems that science is all about. It's really about the planning, not just the knowing.
And this really highlights a huge difference, right? AI is awesome when you give it a clear set of rules and an easy way to check the answer. Think solving a math problem or finding a bug in code. But real research? That's the total opposite. You're stepping out into the unknown, and feedback on your plan? Well, that might take months or even years to get, if you get it at all. And that's a huge roadblock for how we've always trained AI. The old method of just letting a model try millions of things until it gets lucky, that just doesn't fly in most science. You can't run a million trial and error medical experiments, for example. It'd be unbelievably expensive, slow, and sometimes just plain dangerous. So, clearly, we needed a whole new approach. The researchers behind this paper decided to try something different. Something that looks a lot less like programming a machine, and a lot more like, well, how we teach actual human scientists. And this quote from the paper just nails the big idea. Instead of just rewarding the AI for a final result, they decided to treat it like an apprentice, like a grad student. The AI learns by coming up with a plan and then getting feedback on the plan itself, way before any expensive experiments get run. It's all about critiquing the idea at the source. Okay, so how in the world do you build an AI apprenticeship program without a human professor? Well, it turns out they came up with this really clever automated recipe. Let's get into how they built this thing. It all boils down to 4 key steps. First, it reads the existing science. Then, it creates a homework assignment from that. Step 3, it writes a secret answer key. And finally, it gets into this loop where it grades its own work. So step 1, they basically feed the AI a published scientific paper, and its job is to figure out, okay, what was the original problem these scientists were trying to solve? It pulls that out as a clear research goal. And just like that, you have a homework assignment based on a real scientific breakthrough. Okay, now here's where it gets really, really smart. The same AI then goes back to that paper and creates a secret grading rubric. This is the answer key. It's basically a checklist of all the crucial things a research plan needs to have to actually solve the problem, all based on how the original scientist did it. All right, so now we've got our assignment, the research goal, and our secret answer key, the rubric. A new student AI gets just the goal and is told, okay, write the best research plan you can think of. It has no idea what's on the rubric. It's flying blind. And this is where the magic happens. A second AI, which is really just a copy of the first one, acts as the grader. But this AI gets to see the secret rubric. It uses that answer key to score the student's plan. This whole process is called self-grading. And yeah, it's pretty much the AI version of grading your own homework to get better. So, what this entire setup creates is something the researchers call a generator-verifier gap. It sounds technical, but it's simple. Because the grader AI has that secret privileged information, the rubric, its job of checking a plan is way easier than the student's job of creating one from nothing. That gap, that's the engine that drives all the learning, and it works without any human telling it what to do. So that's the AI school. But did all this training actually work? Did the student AI actually get any smarter? Well, let's take a look at the report card. Oh yeah, the results are pretty staggering. When they brought in human machine learning experts to do a blind comparison, they preferred the plans from the newly trained AI 70% of the time. That's not a small difference. That's a huge win. And, this wasn't just some quick survey. To get that result, these experts spent a combined 225 hours meticulously reading, annotating, and comparing everything the AI produced. This was a really deep, serious evaluation. And when you dig in, the results get even better. The experts said the new plans were just fundamentally more solid and more useful for an actual student to start with. They also confirmed the AI-generated rubrics were top-notch, approving 84% of them.
And get this, the method worked great on medical papers and even on brand new preprints, showing it's super versatile.
So, what's the big picture here? What does all of this really mean for the future of how we do science? Let's zoom out for a second. Here is the most important takeaway. This isn't just about building one slightly smarter AI. This is about creating a recipe. It's a scalable, automated blueprint that we can use to train a whole new generation of AI partners for scientists in almost any field you can imagine. And that brings us right back to where we started. We're moving beyond just asking an AI questions. We're teaching it the much harder skill of how to plan, how to critique itself, how to think more like a scientist. The question isn't if AI can help science anymore. The real question is, what are we going to discover with it next?